Welcome, future aerospace engineering students, to this explainer. Today, we're framing your potential future as the ultimate human adventure. We're going to map out exactly what it takes to leave Earth behind, live hundreds of kilometers above our planet, and conduct the kind of work that could, quite literally, transform humanity's future. So, do you have what it takes to leave Earth? And I'm not just asking if you can solve complex orbital mechanics equations, right? I'm asking if you are truly prepared to face the extreme physical, psychological, and academic realities of pushing humanity beyond our home planet. Astronauts are among the most highly trained professionals on Earth, and their journey begins years, sometimes decades, before they ever even see a launch pad.
Okay, let's dive into this. Here's our flight plan for today. First, your path to the stars. Then, forging the modern astronaut, daily life in extreme microgravity, high-tech orbital operations, surviving the hostile void, and finally, a legacy for humanity.
Let's start with Section 1, Your Path to the Stars, the Academic Foundation.
Becoming an astronaut is honestly one of the absolute toughest career paths in the world. Space agencies are selecting only a handful of candidates from thousands and thousands of applicants. To even be considered, you need a rock-solid background in disciplines like aerospace engineering, medicine, physics, military aviation, robotics, or computer science. You see, you aren't just training to be a space traveler. You're training to be a scientist, a mechanic, and an explorer, all rolled into one.
And why exactly do you need to be so highly qualified? Well, think about 28,000 kilometers per hour. That is the mind-bending speed you'll be traveling at once you leave Earth and enter orbit. Navigating and surviving at that kind of velocity requires a foundation of absolute precision and deep understanding. Moving on to Section 2, Forging the Modern Astronaut, the Trials. On land, candidates are pushed to their absolute physical limits to maintain exceptional cardiovascular endurance and strength. But how do you prepare for weightlessness? You actually trade your sneakers for a scuba suit. Candidates spend hundreds of hours in these massive underwater pools simulating spacewalk procedures, complex tool handling, and equipment repairs. It is literally the closest you can get to zero gravity without strapping yourself to a rocket.
But hey, what happens if your return trip doesn't go exactly as planned? To prepare for that, astronauts undergo intense survival training across some of the most unforgiving terrains on Earth. We're talking harsh deserts, open oceans, freezing Arctic regions, and dense forests. If your capsule makes an emergency landing in a remote earthly location, you and your crew need to know exactly how to stay alive until rescue arrives.
All of this physical and survival forging culminates on launch day. Whether you're boarding a SpaceX Dragon, a Soyuz, or an Orion spacecraft, you're going to face acceleration forces exceeding 3 Gs. And alongside those intense vibrations, you'll be maintaining constant communication with mission control. Within minutes, you pierce right through the atmosphere and experience weightlessness for the very first time. Which brings us to Section 3, Daily Life in Extreme Microgravity, Structuring the Void.
Life aboard the International Space Station is totally surreal, but it's bound by a highly structured routine. Your morning starts with immediate health checks, communication briefings, and equipment inspections. Then you dedicate the day to vital research, stuff like fluid dynamics, material science, plant growth, and even pharmaceutical development. Finally, you sleep inside bags that are literally strapped to the walls. Why? Because in microgravity, if you don't tie yourself down, you're going to just float away in your sleep.
Now, notice that I skipped one key part of that daily routine timeline just now, the mandatory 2-hour exercise block. So the crucial point is this: without 2 hours on the treadmill, resistance machines, and exercise bicycles every single day, microgravity rapidly deteriorates the human body. Long-duration missions cause massive bone loss, muscle atrophy, alarming vision changes, and cardiovascular alterations. That exercise, it isn't just to stay fit, it's to ensure your skeleton can actually support your own weight when you finally return to Earth's gravity. Let's shift gears to Section 4, High-Tech Orbital Operations, the Magic Tools.
Welcome to the incredible world of digital twins. These are virtual replicas of spacecraft. Before an astronaut takes a wrench to a delicate system up in orbit, engineers down on Earth use these digital twins to simulate the exact problem, test various solutions, and verify the fix. It's how you troubleshoot really complex mechanical failures without risking the lives of the crew. It's a total game changer.
And digital twins are really just one slice of the pie here. Orbital operations rely on a massive tech ecosystem.
Artificial intelligence is actively used to monitor astronaut health and predict equipment failures. Robotics act as vital assistants for hazardous maintenance tasks outside the station. Meanwhile, 3D printing allows the crew to manufacture spare parts on demand, completely bypassing the need to wait months for a resupply rocket. And next-generation advanced spacesuits are currently being engineered to give enhanced mobility and critical radiation protection for future Moon and Mars missions.
Let's look at Section 5, Surviving the Hostile Void, Emergency Protocols.
Up there, a small malfunction can instantly become life-threatening. The crew maintains constant vigilance against oxygen system failures, sudden pressure leaks, or the genuinely terrifying prospect of a fire in an enclosed, oxygen-rich environment. And outside the station, thousands of high-speed space debris fragments are orbiting Earth right now. Even a tiny fragment colliding with the hull can severely damage the spacecraft.
It's exactly because of these hazards that we come to this really powerful quote. Mental resilience is as important as physical fitness. The physical risks are massive, for sure, but the psychological challenges, they are profound. Astronauts have to cope with deep isolation, extreme confinement, highly stressful workloads, and being vastly distant from their families. The mental fortitude required to stay calm and execute an emergency protocol perfectly while floating in a tin can miles above the Earth is just staggering.
Finally, Section 6, a legacy for humanity, the boon.
The data collected from medical sensors, fluid dynamics experiments, and Earth observation systems doesn't just stay in orbit. It's transmitted down in real time, shared globally, and analyzed to improve medicine, advance technology, and make life better right here on Earth. And this brilliantly illustrates why all of this matters. Today's astronauts are the pioneers literally paving the way for permanent lunar bases and humanity's eventual missions to Mars.
So I want to leave you with one final question to think about. As future aerospace engineers, as the next generation of potential explorers, are you ready to take up this mantle? The training is absolutely relentless. The risks are astronomical, but the adventure, it's unparalleled. Are you ready to push humanity forward? Keep that question in the back of your mind as you continue your studies. Thank you so much for joining me for this explainer. Keep looking up.